So in this case, we are given another typical exam revision as we are to consider our probability questions. So the first part, which is question number 9.1, we are given for any two events A and B, we are given that the probability of A is 0.48, and also we have got the probability of B, which is 0.26. Determine on 9.11, that is the probability of A and B on a condition if A and B are independent events. There is a condition that you must work with for you to determine probability of A and B. So what is the condition of our independent events? So we do understand that as we are working with independent events, for two events A and B to be independent, the probability of A and B must be equal to probability of A times probability of B. That is what we must understand. For events to be independent, A and B. So in our case, we have got the formula already. So let us just substitute because A is there, B is there. So A, that's 0.48 times the probability of B, which is 0.26. So that was going to give us the product of 0.1248 as the probability of A and B, provided that these two events, they are independent events. Then moving on to another part, which is in this case considering 9.12, probability of A or B. If A and B are mutually exclusive events. Remember, we dealt with mutual exclusive events where this is on its own and another one is on its own. There is no intersection. The intersection of these two is actually equal to 0. A intersection B. Number of elements that we have on A intersection B will be equal to 0. So if the intersection of A and B is 0, so we understand that the probability of A or B is simply going to be direct probability of A plus probability of B. Remember, you're supposed to subtract probability of A and B. But there's nothing here to be subtracted. So you just end up with these two, all right? So that is the major case. Understand your concept, guys, of your simplification, all right? So A is there, all right? And also B is there. Just add the two, all right? Which is 0.48 plus that one of B, which is 0.26. So adding these two, we're going to have the probability of A or B, provided that they are mutually exclusive events, and that's 0.74. All right, let's consider another part. On question 9.2, we're given the Venn diagram having the information, that is the survey which was conducted among 130 grade learners to establish which snake they prefer to eat while they watch television. So we are given there are 130 of them. All right. So out of these we are given, the results were summarized in the Venn diagram below. However, some information is missing. So this is what we were given according to the information. That is the chips. Then we've got nuts. Then we've got the dried fruit, which is D. Okay, so that is what we have according to the information, this and that. All right. So let's see, guys. The first part of our question, 9.21. If X is equal to 29, if 29 learners prefer at least two types of snacks, calculate the value of X and Y. If 29 prefer at least two, So what does at least mean? At least means from what you're given going up. So if we say at least 2, it means 2 or more. 2 or more. That is at least 2. Starting from that 2 going up. At least 1, that is 1 going up. So at least 2, 2 or more. So meaning to say, they are saying here where we have 2 intersection of C and N only is 2. Intersection of C and D only. Intersection of N and D only. And also this one for all three, it is included 2 or more. These ones, it's only 2, only 2, only 2. But this X is for all three. So if they say 2 or more, that is what you're talking about. So these are the ones that we must put into consideration for 2 or more. So they are saying these elements that we see here, they are equal to what? To 29. So we can answer our question from there to find these values. So let me just, okay, 9.21. Let me just answer it here. So 2 or more, their total is what? Is 29. So meaning to say if I take this X, I take this 5, add to X, I add 6, I add this 10, that is where we have got what? 2 or more. We are supposed to obtain a total of what? Of 29. So thus we've got an equation, all right? So that's going to be X, add this 5 plus 6 plus 10, that's 21, which is equal to 29. So to find X, we're going to solve, take this to the other side. So X is equal to 21, 29 minus 21, which is what? Which is 8. So we have got the value of X. From this information, we managed to obtain the value of X, which is what? Which is 8. So this information that they are 29 has nothing to do with Y. But they were asked to find X and Y. X and Y. So what about letter Y? What are we going to do? Since we have got X, we can find Y. As we can see, we have got every portion, every part is represented. It's only this Y that is missing. So we can simply solve an equation from the total of 132. So Y is equal to, 130. 130 minus what? Everything that you see. There is a 41 plus a 5, a 25. All right. The X, which we calculated, which is 8, the 6, the 10. All right. And the 30. So you combine everything, thus you're going to have the value of Y there. So, right, let's combine everything. That's 125 from your calculator. Thus you're going to have a difference of what? A difference of 5. So Y is equal to 5. Those ones who do not take any of the given snacks that are provided, they do not take any of the given. All right. Anyways, let's see. On another section, that is 9.22, determine the probability that a learner who does not eat nuts, will either have other snacks or no snack at while watching the television. The person who does not eat nuts, okay, who does not eat nuts. So this is what we have. These are the ones that eat this one. They eat nuts. These ones. So let's cover this. Because they do eat the what? The nuts. But the question is, find the one who do not eat. Meaning to say, it is about these ones that are remaining. But out of those that are remaining, they are saying that person that does not eat the nut, will either have another snack, meaning to say this person can choose or to have chips, dried fruit, or both, any of these. So meaning to say this section is there. It is included because we can choose another snack or what? Or no snack while watching television, or no at all. Meaning to say these ones that are outside, they are also involved. They are also involved. So we're talking about these ones that can have other snacks. And those ones that do not even have, they don't have any other snack to consider while watching television. So thus we're going to take everything that we see which is left outside. So there's a 41, a 10, a 30, and a 5. So know the exact position that you're talking about. So it's just like probability, not n, not n. Because what is not in n is these are the ones. Those are the ones. So let's take this one. There is 41. There is a 10. There is a 30. There is a 5. All right. Everything over what? The total of 130. Just like that. Remember the 5 represents y that we calculated here. So that was going to give us a total of 86 over 130. Reduce this one. That's 43 out of 65, or as a decimal, 0.662 two decimal places. All right. So that's how these questions are given. Let's consider another part. 9.3. We are given that there is a group of 200 tourists who visited the same restaurant on 2 consecutive evenings. On both evenings, that is those 2 consecutive, the tourist could either choose beef or chicken for their main meal. So we have got 2 things that are to be considered. Then this information, draw the Venn diagram, this and that. So from that information alone that we are given, remember, I wanted something for the tree diagram. Anyways, let's see. There are 2 of them. All right. Beef and chicken. That's B and C. So that is the branches that you're gonna consider. There are 2, beef and chicken. So that's our first pick. Then we pick again from that beef, chicken, beef, chicken. All right. So this is it. So that's 2 consecutive. First pick and the second pick. Then we consider to say, they said, according to this information, the manager observed that 35% of the tourists chose beef on the first evening. On the first evening. Remember, a percentage is a probability. It's a probability. 35% means 35 over 100. That's 0.35. It's a probability. All right? It's a probability that we are given there. So this one we are given that 35% of the tourists, they chose beef on the first evening. So this is the first part, the first evening. The beef, it was 35%, meaning to say as a decimal of our probability, that's 0.35. We are given that one for beef. Okay, no problem. Then what happened? And 70% of them chose chicken on the second evening. The second evening, whether the first one you chose beef, but the second, as long as you talk about the second evening, the second pick, chicken, it was 70%. Wherever you see the part of C on the second part. So as a decimal, that's 0.7, 0.7. So this one is a guided question. It's a guided question. We are not given this one. We are not given this one. We are not given this one. Why? Because they know that you must understand probability. As long as you talk about this branch as it is, B and C, you must get a 1. So to find the remaining part of C, we can simply say 1 minus 0.35. So that's going to have 0.65. The same thing, here we must get a 1. So 1 minus 0.7, that's what? 0.3. 1 minus 0.7, 0.3. They know you can fill in like that. So that is the condition. Then your outcomes B to B. So that's beef, then chicken. You can choose chicken the first night. The second night, you choose beef. You can choose chicken the first night. All right. You choose chicken the first night. Then the second night, you choose chicken again. So this is what you are being asked to represent. These are the possible outcomes. All right. So that was our question. That is of the representation. Represent 9.31. Represent this on a Venn diagram. As we are representing, show all these branches and the possible outcomes. The 9.3 to calculate the number of tourists who chose the same meal. That is, their main meal was the same. On both evenings, on both, they chose the same. Meaning to say the first evening, it is beef. The second one, beef. First evening, chicken. The second evening, chicken again. Both, same. Same thing. So that is what you're given there. So 9.32, it was a direct question because we need both, which is the same main meal. So same, it is just like same color or same whatever that you're given. So that's beef. Beef. We also have chicken. All right, just like that. Same. So beef to another beef, you multiply along 0.35 times 0.3. Remember our simplification. All right, 0.5 times 0.3. Then we move on, plus chicken to chicken. This is chicken to another chicken, 0.65. Another chicken, 0.7. Just like that. So you're going to combine these. The first one was going to give us 0.105 plus. The second one was going to give us 0.455. Then adding these, that was going to give us 0.56. Meaning to say, as a percentage, the probability, you can even have it as a percentage, it simply means 56%. That is what you're given. All right, let's go. The question is calculate the number of the number now, the number. So this is the probability here. Those ones who had same meal, same main meal. This one, it is the probability. We calculated the probability that there is 56% chances of this happening, or 0.56 chances of this happening. So how many now, top of the number of people, the clients who were there? How many members, how many clients are we talking about? So it will be 0.56 times the number that we are given of our clients. There are 200 tourists times 200. So there we name the number of tourists now who chose both, which is the exact the same meal. So that is 112 what we're having. All right. So answer the question. We have the probability first, then answer the exact thing. Wanted the number of tourists. The number of tourists. So that is what we are given. All right. Anyways, let us consider another part. Show that more tourists opted not to change. More tourists opted not to change their choice of meal during their 2 visits to the restaurant. More opted not to change. Is that so? More opted not to show that more tourists opted not to change. All right. So this is it. Not to change. Not to change. What does it mean? It means you are not changing. If you take beef the first night, the second one it's beef. If it is chicken, chicken. So they're saying, can you show that these tourists 112 that we calculated, because these are the ones that did not change, these ones, they did not change their main meal. These are the clients, 112 of them. So how can we show that truly they are more? We compare them from the total out of 200. So how many changed out of 200? How many changed? All right. So those who changed the meal, the number of tourists who changed the meal, their main meal, who changed the main meal is going to be 200 minus those ones who did not change, 112. Those ones who chose both for both nights. They were using this. They were taking the same meal. So those who changed the meal, how many are they? We just subtract from there. That was going to give us 88. So comparing 112 and 88, we can see that 112 is greater than 88. So therefore, we are saying these ones, they opted more. More tourists opted not to change. These ones, they did not change. All right. So therefore, more tourists opted not to change. Opted not to change. Not to change their choice, that is of the meal. Their choice of main meal. That is the condition. During these 2 consecutive visits that they had. So some questions you compare, it's like remember probabilities, just like financial questions where there are some real life situations or real life questions that you must use according to the type of question that you're given there. So to answer these, do revise as many questions. Figure out how do they ask these typical questions. So that is it, guys, on our revisions. Let us just add as many questions as we can till we meet again.